What if every planet was as big as Jupiter? Artificial intelligence shows. Imagine if every planet in the solar system was the same size, as massive as Jupiter. From Mercury to Neptune, each celestial body becomes a giant gas world. What would happen to their gravity, climate, orbital paths, and potential for life? Let's find out, with the help of AI, in a journey across a transformed solar system. Mercury is the closest planet to the Sun. It's only 4,879 kilometers in diameter, making it the smallest planet. A Mercury day is 176 Earth days long, while a year lasts just 88 days. Surface gravity is only 0.38 g, barely more than a third of Earth's. Scaling Mercury up to Jupiter's size, over 140,000 kilometers in diameter, would dramatically destabilize the inner solar system. Being so close to the Sun, such a massive planet might pull the Sun closer, or even spiral into it. Its gravity would exceed 2.5 g, making it extremely dense. Mercury's thin exosphere would be stripped instantly, and its surface would likely become a superheated gas envelope. Venus is Earth's twin in size, but far more extreme. 12,104 kilometers diameter, with a day longer than a year. 243 days versus a 225-day orbit. Surface temperature, 460 degrees Celsius. Thick carbon dioxide atmosphere with sulfuric acid clouds. A Jupiter-sized Venus would become a hellish gas giant with a crushing atmosphere thousands of times thicker. It would likely rotate faster, creating massive global storms and high-speed jet streams. Its greenhouse effect would be unimaginable, possibly a runaway inferno. Earth is 12,742 kilometers in diameter, with 1 g gravity. 1 day equals 24 hours. A year equals 365.25 days. Average temperature, 15 degrees Celsius. It supports water and life. Gravity would skyrocket to 2.5 to 3 g. Humans couldn't survive. Bones would crush, organs collapse. Oceans would deepen, mountains flatten, atmosphere thicken. The day could shrink to just 10 hours due to fast rotation. Life, if it existed, might evolve to float, swim, or hover in thick atmospheres. Mars is just 6,779 kilometers in diameter. Gravity, 0.38 g. A Mars day is 24.6 hours. A year is 687 Earth days. Cold, dry, and dusty, with polar ice caps and thin air. Mars would transform from rocky desert to a cold gas giant with swirling methane clouds. Gravity would be too intense for human life. It could host moons and complex atmospheric dynamics. Mars might retain reddish tones, but would become a deadly giant in the outer solar system. Jupiter is already the largest, 142,984 kilometers wide, 317 times Earth's mass, 2.53 g gravity. Day, approximately 10 hours. Year, 11.86 Earth years. The Great Red Spot is a 400-year-old superstorm. Saturn is 120,536 kilometers wide. Its rings span over 270,000 kilometers. Day, 10.7 hours. Year, 29 Earth years. Gravity, 1.07 g. The rings would expand proportionally, stretching hundreds of thousands of kilometers. Atmospheric storms would intensify. Its moons might collide or destabilize due to altered gravity. Uranus has a diameter of 50,724 kilometers, rotates on its side. Axial tilt is 98 degrees. Day, 17 hours. Year, 84 Earth years. Tilted Uranus would display bizarre light cycles, with poles facing the sun for years. Ice clouds would swirl violently. Aurorae and magnetic anomalies would light up the skies. Neptune is 49,244 kilometers wide. Gravity, 1.14 g. Fastest winds in the solar system, over 2,000 kilometers per hour. Deep blue color from methane. The winds would grow even faster, possibly breaking sound barriers. Enormous pressure might form diamond rain inside the planet. Neptune would become a storm-dominated ice giant, ruling the edge of the solar system. The solar system, as we know it, exists in a delicate balance. Size matters. A slight change in mass, rotation, or atmosphere, and everything we take for granted collapses. These planets are not just distant worlds. They are warnings. If Earth were larger, we might not be here. If Mars had just a bit more mass, it could have evolved life. If Neptune moves one moon too far, chaos begins. The universe is not stable by default. It is balanced, barely. Thank you for exploring this AI-generated cosmic experiment. Don't forget to like, subscribe, and share if you want more scientifically grounded, visually epic journeys through space and imagination. This was Absolutely Anything. Stay curious and stay small.